So, welcome again to my Masterclass 101. So, today we're going to discuss the application of integration. We will apply in the area. Area. Under this area, we can use it under the curve, under the curve, and area between curves. Area between curve. So these two are the topics under the area, again under the curve and between the curve. So let me introduce to you the concept of the area. First, we do our graph here, then we do a line from here to here. So after I put my curve right here, then I put my x and y right here, then a origin right here. So let's put our curve right here is y equals to f of x. Then we are determine our area right here. Okay. Then area again right here is equals to b. So after I put the area a and b right there, the boundary, then I will shade the area that we're going to solve. This area here and here. To start our solution, we took a point right here and put, because we don't know the point right here, because a point the x and y right there, because we don't know what is it in there. And from this point I will draw my vertical strip right here, and to shade it. Yes. So this is my rectangular vertical strip. So from this origin to the distance of my vertical strip is equivalent to x. Then this thickness of our strip is x right there, will be dx. After that, we take out this vertical strip. We identify our dx, the thickness of this, and our from origin to our area, and we get our vertical strip out right here. After we take out our rectangular strip, because why is this is dx? Because this is along the x-axis, we call it dy if along the y-axis, right? If x-axis right here, if pointing in the y, this is our y right here, is called dy, and pointing to d is dx. And the height of vertical strip right here, sorry if I forget, the height of this is our y, then our origin is x. So after that, we're going to get our vertical strip doing this, get it out, and this will be our y right here, the length of this, and dx right here under this, and we get our differential equation, so called is dA equals to y dx. After that, we integrate it. Integral of dA equals to integral of y dx, and we get our limits. Our limits right here is a and b, right? We put area equals to integral of p limit to a y dx. And that's our how to do our area curve. It's familiar right here. And I will give you some examples after this. So this is my example in our area. First, we're going to do right here our method. The what to call is tabular method right here. The first is tabular method. Tabular method. We start it from x and y, then 0. What's value is 0. We go 1 here, then 4, 2. After that, we're going to take our solution right here with our graph right here. Sorry. After that, we put a line right here, our x. Then our line right here is 0 to 4, and this is our curve. This may be our curve. Be like that. And we put our x and y, square root of x right here. Then our x and y right there, we identify it by doing these points. This will be 4 right here, point, and this is a point right here, and to 0, and to 2 right here, our 2, and our 1 right here. Then we do our taking our vertical to put our area here. Then you put some point there because we don't know what is here. Then you put some x and y. That's that. Then we put our other broken to by match our vertical strip. I will take this area, by the way. Put our vertical strip right here. Yeah, stuff like that. And the area from here to our vertical strip is our x. Then the thickness of this is our dx, right? And the height of this is our y. Then we're going to take out this our vertical strip from here, and this will be like this, our y, and this is our d x under. And we do the dA formula. It's you call the differential area. After that, we get our differential is dA equals to y dx. Then a, our limits, by the way, is 4 and 0. I put our origin right here. By the way, put our x and y. I forgot origin. Then our right here is a equals to, our limits is 4 to 0 y dx. Then we substitute the value in. Our square root is, other value of it is x equals to 4, 0, our square root right here is our y, right? X equals to 1/2 dx. Then we integrate it. The x before, it will be this will be x over 3 halves over 3 halves what is in here, it's under it. Then limits to 4 0. Then we solve it, it will be 2/3 square root of cube limits to 4 to 0. Then we solve it here, it will be area of 2/3 bracket a minus 0. Then we're going to calculator it, and by the way, I'm going to calculate. Where's my calculator? Wait, are we going to calculator? After we calculate it, our final answer of our area is 6 over 3 square units. You can use our calculator by changing it mode by radian. That's all. And thank you. After this, we're going to take another example in our area, other curve. So good morning. So we have another example here from find the area under the curve y is equals to square root of x from x equals to 1 to x equals to 3. First, we identify our graph right here, like this, we do like that. Then, sorry, my electric fan is too strong. Then we identify it from 1 to 3, right? 1 to 3. Then we put our curve right here. It's not like this. This will be our limit right here. 1, 2, and we get this part to do our area. Then we put some x and y right here, y, and this will be our y equals to x squared. Then we put our we will be good for you. Wait, I get my ball pen to see at what area we're going to get. This area we're going to get this right here. Then we put our we put our point right here, because this area we will get that, and put some x and y right here, there, x and y, see that. After we put an x and y right there, we're going to put our vertical strip right here. Then after we putting that, we identify our area of x. This will be our area of x right here. X, this will be our x. Then the thickness of this will be our dx. Then the height of this will be our y. Y. Then after we going to get that, we're going to take it out right here. Then we're going to do the application of integration by using this formula, and we get this dA, that's the real dx by the way, and this is our y. First, we get our formula. This a equals to limits to b and a absolute value fx and dx. Then by the way, what is our limits right there is will be 1 and a. This will be our limits. 1 will be a, b will be 3, 1 and 3 I mean, sorry. After that, we're going to solve it applying the formula. 3 is to 1 limits to a absolute value of square root of x dx. Then solve, eliminate the absolute values by doing this. After we eliminate we get an absolute value 3, 1. This will be square root of x dx. Then we use the power rule right here. Use the power rule. This will be look like this. Bracket 2/3 x over 2/3, 3/3, I mean 3/3, then bracket limit to 1 to 3. After that, we compute this by using our calculator. From here, we can use our calculator. It's easy to compute. I compute this last time. Is my answer in my calculator is 2, 3, 2 square root of 3 minus 2/3. And this is our final answer. This is how to get a area under curve when y equals to square root of x from x equals to 1 to x equals to 3. So next, today we're going to tackle about area between curves. So in the area between curves, there are two types of lines right here. And first, there will have our first curve right here. This will be our first curve. Then the other curve will be like this. Then the first curve, we will label this as y1 equals to f1x. Then the second will be our y2 equals to f2x. And this is our area between curves. So when you say area between curves, the area will be here and here, and this is our b, the area, and here. So after we getting the area here and here, we do our point right here. This will be our x and y, and we will put our vertical strip right here. And just look like that. Also, we are going to extend right here our vertical strip to down, and another area from here. And this vertical strip. Also, this part will be our x2, y2 right here. This will be x1 and y2. Then after we putting our vertical strip right here, the area of our x is here and here, x. Then the thickness of this is our dx. Then also our y1, the height of this is our y2, right? Then the height of this from here to here is our y1, and this is our b and a. No, this will be our area A and area B. Also, our problem in here is going to get this here and here height. This will be our y1 and minus y2, and that is problem our getting our height. Okay. Then we're going to get our strip right here, and this will be our y1 minus y2. This will be dx, right? And formula base again is dA. dA equals to y1 minus y2 dx. Then after that, the area will be integral of a to b equals to close parenthesis y1 minus y2 dx, and this is probably formula.
So we have some examples right here, and this is our B example between curves. First we're going to do is identify is this is our x1 and x2. There will be our limits is a is equals to 0 and b equals to 1. First we're going to do is our get our limits area a and b right here. Then the first is getting this part. This will be our x equals to y, right? Then this will be our first vertical strip right here, then a second right here, then this will be x area. We have x right here, then thickness will be our dx. Then the height of this is will be our x y2 I mean. Then the area of this is will be our y1. Then this part is missing right here, right? And this is will be our y1 minus y2, and we're getting this part, and we're going to apply here the integration using this our y2 and y1, right? And by the way, I forgot, this is our be x2 and y2, and this is y1 and y2 right there. Then we get this part, then we solve it. Apply our integration right here. First we're doing this, it's y1 minus y2 dx. Then we're going to solve it by using our formula right here. Is a equals to square root of b a is equal to f of x minus g of x dx. Then we're going to substitute it by doing this. Limits of 0 to 1 is x equals to x squared dx. Then eliminate the absolute values. 0 to 1 x minus x squared dx. Then we're doing this 0 to 1 x dx. So 0 to 1 x squared dx. Then we apply here some rule, right? And the value of this is will be 1/2, and the value of this after resolving this will be minus negative 1/3. After we computing it, this will be 1/6. By the way, sorry if you didn't see, I compute this part. This the answer is will be 1/2. If I compute this part squared, and the answer is 1/6. But third part, sorry, my alcohol.
So next of our lesson, we have the polar curves or polar equations. First, we are introduce to you the polar curves. First of it is our Cartesian coordinate system. It's look like this. Our Cartesian coordinate system, and this is our dy and x right here, and this is our b. I'll put some triangle here. This part is called in Pythagorean theorem. This will be theta right here, and this is will be equals to d, right? D equals to square root of x squared plus y squared. R, this is will be r, and this part p, and x and y right here, and this is all be y. After we doing that, we get this part. By the way, forgot this is our bx. Like in Pythagorean circle, this is our Pythagorean circle look like, right? may look to you, may see to you the Pythagorean circle looks like. That is Pythagorean circle in our polar coordinate. In I will explain to you after we see that these are polar, or after we finish the polar side. That is look like of our polar plane. By the way, after I saw to proceed to you the our polar plane, next we're going to solve this part. We get this angle. It's look like this. Our theta right here. R. This will be our y equals to r sine theta, and this will be x equals to r cos theta, and the formula of this will be r equals to x2 squared plus y. Then, did you see this Pythagorean circle? Right? After we see that, we're going to do that is our polar plane. Right? This will be look like this if our sketch this, by the way. This look like this after we introduce to you our polar plane. First, we're going to do this. We put a big circle. Ay, sorry. I put another space. Right here, we put our big circle. Sorry, I will sketch this. Then, after I sketch our circle with graph, then this part will be our 0, 90 degrees, 180 degrees, and this part is 270 degrees. Then we put some triangles right here, this and this. We put this. It's represent this also the Pythagorean circle. I saw to you, this is Pythagorean circle. I learned this, I saw this Pythagorean circle when I was in grade 9, the Pythagorean theorem, solving the sides of a triangle to a squared, b squared, and c squared. So first, we're going to sketch our polar plane right here. Then right here and here. Sorry, I not good in sketching, but good on eating. Joke. First, this circle right here is our radius 1, R1. Then, no, it's R1 equals to circle. Then, second circle right here is equals to R2. This will be our 30 degrees, 60 degrees. This will be 120 degrees, 150 degrees right here, and this will be part is our 210 degrees, 240 degrees, 70 is 300 degrees, and 300 degrees and 330 degrees. And this part is 0 is also our 360. And compared to our Pythagorean circle, it's look like this right here. Their values right here is 1/2. Their values here is the values in the inside of it is right here. Did you see the values? Pi over 2, 2 over 3 is pi over 6, 0, 0. Then this is our value right here. You see that? After we introduce to you this polar plane, and this is our Cartesian coordinate system. So I have some examples right here in our polar area. So first we identify our circle is 6, then equation this is x squared plus y squared equals 18. Then to solve this by using this formula is this will be r cos theta plus r sine theta, and then we'll have a squared right here and equals to 18. Then r squared cos squared theta plus r squared sine squared theta equals to 18. Then to solve this is r squared close parenthesis plus sine squared theta equals to 18. Then equivalent of this is 1 equals to r equals to 18. Then value of 18 is 6, right? 6. Sorry, I thought 6. 6, right? And this equation is a circle in polar form. So we do our circle by using the polar curves. So after we get our polar form, we use the solve our polar curve. So this part is 0 and 90, and this is r equals to 6, right? Then we get our triangular strip right here, and this part will be r, and this will be d theta. This d theta, and we cos it, and we take out this. This will be look like that. This will be r and r d theta. Then the formula of this is dA equals to 1/2 r squared d theta. And to solve this is a area equals to 1/2. Our limits, by the way, is 0, and if you see our Pythagorean theorem, that value of 90 is 1 pi over 2, right? And this part will be our limits pi over 2 and 0, and our value here is 6, right? 6 squared d theta equals to 18 theta to theta equals to pi over 2, 0 equals to, from here we can use our calculator, and the final answer will be 18 pi square units. From here we can use our calculator, and that's all. So today may I teach you our volume using integration. In volume using integration is under this method, shell method, and Paasche method. So today we're going to tackle about this method. First, I have graph here. To understand it, we have a curve right here, it's y f of x, and we have some point here represents our x and y. Then our vertical strip here. Then we put our limits to a to b, and the height of this will be y. By the way, our disk is using AOR. The AOR is area of rotation, right? Our disk will be from above of this strip. We're going to do that round, and because using AOR, and this will be our disk. After we taking out our disk, we move to this part. After we take this out, this will be our center. This is our AOR. Thickness of this is our dx, and the height from here to here is our y. The formula of this is simple. If you remember your cylinder formula, volume, this will be like this in our high school, right, or elementary. This is a formula in our cylinder, right? Pi r squared h. Like in our disk right here, this will be look like that. dv equals to pi y squared plus 2 dx. This is will be dx. Then after that, we're going to go integrate it by b limits to integrate v equals to integral of a limits to b pi y squared dx. So I have some example right here. The volume area, the line under the line y equals to x from x equals to 5 to x equals to 0 is rotated about the x-axis. First, we're going to identify our limits is 0 to 5, right? Then we find this our area. Then after that, we point here our x and y, right? So right here. Then we do a vertical strip right here. We occupy this area. Then this part to this part is our x, and this part of thickness of this is our dx. Then the height of this is our y, right? And we rotate our disk from here to here, and take that. It will be like this, and this will be our, by the way, this is not dx, this will be our dv, right? And we take out this, like that. Then this part is our AOR, and this part is our y here, height, and this part is our dx, and the formula taught to you is volume pi squared dx. Then volume equals to 0 to 5 pi squared dx. Then solve this. From here we can solve this 5, our x and pi y squared, this will be x squared dx. From here we can solve our equation by using our calculator. Pi, take out our pi, 9. Oh, by the way, I forgot the pi right here. Pi, from here we can solve our equation. Pi 5 to 0 squared, pi, solve this will be x cubed to limits to 5 to 0. Then I calculate in calculator in this part. This will be our pi over 3 to 125 cubic units, and that's our volume. And this should be our final answer. So today, the next our lesson to teach you is our shell method. First, shell method is like a shell of a tin can. Tin can, maling, kumbaga dumaling, tsura kang shell method. Ramo. Ang shell method nga rando, pabilog sa nga lata, lapad nga lata, kumbaga dumaling gani, dumaling sa. First, we are going to do that by identifying our area right here. This will be our area, and we will label it as A and B. Then we put some point. Let me use a different ball pen. This will be our X and Y right here. Then this will be our vertical strip, rectangular strip I mean. After that, this is our vertical strip, and we identify this is our area of X, right? From X. Then this part is our dx. Then after that, this is our height, right? Our y, the height of our shell. The shell method is also do this like our disc is rotating. It's also rotating, but it's rotating like a shell. From here to here, rotate that, and here to here, we're revolving from this. This look like shell, right? Shell or kumbaga lata ni sa lata nga ma-compare naton sa maling. Pero kaan mo siguro maling, akay hindi mo maling. Then the AOR will be here. The rotation na muna rotation nyo, kumbaga halin di na AOR na. Ano yung AOR? It's area of rotation. Pagtapos na itong butang di, paunta di butang ko, we put here, put our shell here. This part is our y, the height, right? The height y, and this part is the thick of it is our dx, and from center of this is our, like I said, this is our AOR, and from center of this is our x. That. Then kung maling ut doon mo sa tunga, palapadon mo, baga doon nag-rectangle siya, no? Amo ni tsura yo. Maling sa baga maling alata. That doing this, and this step is going to 2 pi x, and this side is going to y. This thickness of this is our dx, and this part is this will be a dv. Waga. After we're getting these parts, and we cut it from half, right? Ipalapad ka bagagimo ang rectangular strip. Tapos ang formula is volume limits from B to A equals to 2 pi x y dx, and that's all. So next, I have some examples right here. Volume area under curve of y equals to x squared plus 4 from x equals to 0 to x equals to 2 is rotated about the x-axis. Right? First, we identify our line. The line here will be from here to here. This will be look like this. And this. Our line that is will be y equals to x squared over 4. Then we put our area right here. We get this area. Then we put our vertical point right here, and this will be our x and y, and this will be our vertical strip right here. Then this will be our dx here, and their small part here is our x. So small part is here. This will be our x. Then the height of this will be our y, right? Then after that, we revolve this part and look like this. We revolve this like this, and this, and this, and here to here. It's look like this. So this is our, yes, I think we're revolving right here, right? Then we get this part. We're doing this. That. And this in the center is our AOR, right? What is AOR again? It's area of rotation. And this part from AOR to this part is our X. And this part is height is Y. Then we're going to cut this in half. So it will be look like this. Y is our height here. Then 2 pi x here, and this is our dv. Then to solve it by doing this, dv equals to 2 pi xy dx. Then v equals to our limits right here. By the way, after convert this integral formula, a to b 2 pi xy dx. Then doing this, it's pi. By the way, therefore our limits here is x our limits there is 0 and b 0 and 2, but I mean 0 and 2 our limits, right? Sorry, we put here 2 and 0 pi negative x squared plus 4 is 2 dx. Then I will use the calculator to solve this. Here's my calculator. And the final answer of this is pi. I solved this last time. 2 pi 5 6 equals to 15 cubic units. And that's all. So the next lesson we're going to talk is washer method. The washer method is classified as disc with a ring inside, with a hole. Baka do donut sa. Kung para kaon ka donut, Dunkin Donut sa mga natsura. First, we identify our one right here is this will be our point. This will be x and y. Then we put some vertical strip right here. Look like this. Then after we put that, we identify the area of x here and dx. Then the height of this will be y, right? Then after that, we revolve this part. This will be look like this, with a hole inside here, with a line here. This will be a line here, and this will be pointing here, and here from here the line will be look like a hole. Our x and y is covered up, a hole there. Then the rotation of this will be our AOR inside. Then this will be our B right here. Then the height of this from this, the height of this will be our B. Said this is our B, and this is equal to y equals to B. Let's just look like our this method. Then we take this out right here to what is look like, because my sketching is too edgy. Look like this, and this look like donut, but not donut, it's namit. Then from here to here, it's our AOR, area of rotation. And from here to here is our height of B minus y. By the way, this part is, we're going to find it, this will be our B minus y, right? Then this part to this part is our, will be our B. Then this thickness of this is our dx. Then the formula of this is will be dv equals to pi b squared dx minus pi by b minus y squared dx. Then integrate it, this will be a limits to be pi b squared minus plus parenthesis b minus y squared is dx. Then that's our washer method. So the washer method, like I said, is look like donut, but not donut, it's namit. Then we solve some example right here. So first, find the volume y equals to negative x squared plus y, and x squared equals to 4y, 4 minus y, 2 x equals to square root of 4 minus y. First, we identify our line right here. This will be our line, stuff like that. Then we put our vertical strip right here. This will be our x and y strip, and look like that. And after that, we identify our x. This will be our x right here, x, area of x, and the thickness of this is our dy. It's laying at y. Then the height of this is our y. After that, we revolve this, the AOR of this. This is our AOR, area of rotation, and we'll revolve this. After that, we do this part by doing this. Again, fold this from here to here. Yeah. Then we put some hole right here. Hole right here. Stuff like that. Then the hole that is equivalent to this part. By the way, this part from here to here is our 3. Yes, this is 3. Then this is part is our 3 minus x. And that's all. And we're going to take out that by doing this. We get our donut. Then doing that, this part is our This part is our area of rotation. So part is 3 minus x from here to here. It's 3 minus x. Then this part to there is our 3. Then this part is our dv. And this the thickness of this is our dy. Then solve it. First we're going to do is dv equals to pi 3 squared dy minus pi 3x squared dy. Then volume equals to 4, 0. Limits 0 to 4. By the way, our limits is 0 to 4. Yeah, 0 to 4. Then pi 9 3 minus x squared. So this is it's dy. Then pi 4 0 9 minus 3 minus square root of 4 minus y and square y. Then we are solved it. We're going to solve it again. We simplify it by using calculator. This will be 7.398. Therefore, this will be 24 pi cube unit. And that's all.